1.5. Describe angled pair relationships. Vocabulary. Complementary angles. Complementary angles, this is a symbol for angles. Angles add up to 90 degrees. So this angle and this angle would be complementary. Now, they don't have to be right next to each other like that. They could be something like this, as long as the numbers are in here, like 70 and 20, that you know they add up to 90. Supplementary angles add up to 180. They make a straight line, like that. Adjacent angles, they share a common side, but not any common interior points. So this angle and this angle are adjacent angles. They're next to each other. They don't overlap though, but they share that side. A linear pair are, it's got to be an adjacent angle first, and they have opposite rays on one side. So if we think about it, like this, and then some sort of angle off of it. These are a linear pair because they're adjacent, they're next to each other, and they share this side. And then they also are formed on about are two opposite rays. So this would not be a linear pair because they do not share an adjacent. They're not adjacent. And then this would not be a linear pair because a pair means two and that's three of them. So these are not. Vertical angles, I always tell everybody they are bird beaks kissing. So they form this X, and they're made of two opposite rays. So they have to be straight lines to form it. Like this would not be a vertical angle because this one does not form a straight line here. So not a vertical angle. Example 1. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So 52 and 38 equals 90. So these two angles right here are complementary. So we need to name them. So we put our angle sign. Remember, the vertex has to be the middle letter. So CDB, and then ABD angle. And they are complementary. Okay, what two add up to 180? We have the 128 one and the 52 one. So those are angle ABD and angle CDB. and they are supplementary. Okay, because angle CDB and BDE. So make sure you find everything that I talk about. So CDB and then BDE share a common vertex. They are adjacent angles. This doesn't make a linear pair because it's not a straight line, but they share this and they don't have any common interior points, so they are adjacent. Let's look at this little box over here. In example 1, BDE, let me erase it so we can see. No, can't see. Okay. Yeah. BDE and CDE share a common vertex, but they share common interior points, so they are not adjacent angles. So they overlap some, so they can't be adjacent. Okay, next. Let me blow this up some so we can see it. There it is. Okay, find the measures of complements and supplements. Given that 1 is a complement of 2, and measure 57 equals measure angle 1, or measure angle 2, find measure angle 1. Okay, so these are complements, so we know that they add up to 90. So we say measure angle 1 equals 90 minus measure angle 2. And then let's put in our words. So our numbers, 90 minus 57, and that equals 33 degrees. B, given that 3 is a supplement of 4, and 4 equals 41, find measure angle 3. It's always good in geometry to go ahead and draw a diagram so you can visualize the answer. So a supplement of means they add to 180. And we're going to subtract the measure of angle 4. So 180 minus 41, and that equals 139. Okay, go ahead and do the checkpoints at the bottom. Stop the video and then start again when you're through. Okay, example 3, find angle measures. We have a basketball pole, and they form a supplementary angles with the ground. Find BCA in the measure angle DCA. So in this box, in a diagram, you can assume that that a line that looks straight is straight. So this bottom line is a straight angle. Okay. Use the fact that 180 degrees is a measure of supplementary angles. So we can say that BCA and DCA together is 180. Now let's substitute for what we know. What do we know about the measure of BCA? We know that it's 3x plus 8. Notice that we did put in parentheses in case there was any negative signs to mess this up. And DCA equals 4x minus 3. So now we need to combine like terms. 3x and 4x is a like term. So we add those together, 7. 8 minus 3 equals 5. We're going to subtract 5 from every side, both sides, to get 7x equals 175 divided by 7, and we get x is 25. Now, is that our answer? No, because we want to know what those angles actually are in the measure. So we're going to substitute 75 back when x is 25. So let's write down our expression again for BCA, which is 3x plus 8. So we need 3 times 25 plus 8. 75 plus 8 is 83. DCA equals 4x minus 3. 4 times 25 minus 3, that would be 97. So the angle measures are 83 and 97. Make sure you don't just stop with x. Go back and read the instructions and make sure to actually give us the answer that we want. Okay, again, do the checkpoint at the bottom, stop the video, start it again when you're ready. Okay, example 4. Identify all the linear pairs and all the vertical angles. In this box in the diagram, one side of angle 1 and one side of angle 4 are opposite rays. So they're talking about this side and this side. Are they linear pairs? No, because they don't share a common side and they're not adjacent. Remember, a linear pair has to be made of 2 angles, not 3. To find vertical angles, look for angles formed by intersecting lines. Okay, so 3 and angle 1 are vertical angles. They are made of intersecting lines, bird beaks kissing. Now, these are not, again, because this is not the whole angle. They didn't. If they had given us a symbol for this angle, we could have said 2 and whatever that was. But they didn't, so they're not vertical angles. Now, let me erase that again. Okay, well, let me again. To find linear pairs, look for adjacent angles whose non-common sides are opposite rays. So linear pair, angle 1 and angle 2 are made of a straight line at the bottom. Now, that's the obvious one, so a lot of people stop right there. But do you see this one? Angle 2 and angle 3 are also linear pairs. Okay, checkpoint. I'm going to go ahead and look at that checkpoint with you because there's a tricky thing in here. Identify all the linear pairs. Now, in here, are there any 2 angles that are adjacent that make 180 degrees? No. It takes 3 angles out of any of these to make 180. Like 1, 2, 3. So there are no linear pairs. Now, are there any X's in here? Are bird beaks kissing? Yes. There are 3 pairs of these. So make sure you find all 3 pairs. Alright, start the video again when you're through. Example 5. Find the angle measures in a linear pair. 2 angles form a linear pair. the measure of one angle is 4 times the measure of the other. So we draw a diagram and we say, okay, the little one must be x then, and the other one must be 4 times x. So we can use the fact that angles of a linear pair are supplementary to write an equation. So x plus 4x must equal 180. Combine like terms, 5x equals 180. Divide by 5. X equals 36. Is that what we want? Find the measure of each angle. So the measure of the angle, just plain x, is 36. And the other one, 4 times x, 4 times 36 equals 144. Okay, next page. Checkpoint. Go ahead and do this checkpoint. Start the video again when you're through. Okay. Concept summary. There are some things that we can assume from this diagram and some things we can't. Let's talk about things we can't assume, because that's usually where we get in trouble. Okay, doesn't it look like B is in the middle of A and C? Well, it may be, but we can't assume that since they didn't mark it. Look at the little hash marks here below. If it was in the middle, and the diagram wants us to know that, then it has these little hash marks. Now, doesn't it look like this is a right angle, ADB, or ABD, sorry. It does, but again, we can't assume it until they have that little box there. And the other thing we can't assume is that this angle and this angle together make a complementary angle, or that they're equal. Again, if they're equal, they're going to give us these little round arc notations inside of them. Here's what we can assume. We can assume that all the points here are coplanar. We're not going to try to mess you up and say, oh, A is floating above the plane. No. So we can say that A, B, and C are collinear. If they look like they're on the same line, they are in the same line. Another thing we can say is that there is an intersection between these three, and it is at point B. We can assume that DBE and EBC, they're adjacent. So if they're bumped up next to each other, they are adjacent. And angle ABC is a straight angle. And point E lies in the interior of DBC.